And today I want to start the discussion on decision processing. As you can see at the top of my notes, there are a number of pages in the book that talk about this. There's more examples. If this gets a little confusing, you can go in the book and find some more examples with some nicer pictures than mine. I recommend that maybe you read those over as well. So far, all your programming projects have used sequential processing. Do this, do this, do this, do this. The only exception to that is your try-catch now, right? In a way, it's not sequential. You hit an error, you jump, and you quit. Decision processing is very similar to that. When I first saw try-catch, I wasn't a real fan of it. I said, why don't we just put if statements in and catch this? You won't see too many try-catches in my intermediate programming logic class, because we try to anticipate all the errors that a user can make and intercept them and tell them what's wrong. Try-catch is really designed for you did something that I didn't even anticipate. Well, if you do that and you crash the program, then now I can anticipate it and I can add it to the code. So I don't use try-catch a lot, but it's a good way for you in this class to keep your program from crashing if the user gives you bad data. What we're going to be talking about in this unit is decision processing. Remember from way back, unit 1 or 2, whatever it was, we talked about the different kinds. There's 3 basic kinds of blocks of Legos that you can use to solve logic problems. Sequential processing, you've got a pretty good handle on now. Decision processing and repetition processing. Repetition processing is next month. Though today's already the 22nd, it might be a little into next month before we get to it. But we're going to talk about that. And by the time we get done with repetition processing, you'll have all the tools you need to solve logic problems in computer programs. Doesn't make them easy to solve, but you've got all the tools that you need to do that. So in this unit, we're going to be teaching our programs how to make decisions. If the user turned down the checkbox, do this. If the total amount of the checking account balance is negative, do this, otherwise do that. Yes, no type questions is what we're going to be taking a look at. We'll also be looking at multiple choice questions. I have 3 radio buttons. What's your favorite hockey team? If it's the Bruins or the Blackhawks or the Red Wings, click a button. Which one did they click? That's not a yes, no question. But processing can handle that as well, and we'll learn how to do that. Usually the decision is in one of 3 types. If something is true, do something or skip it altogether. If it's not true, just don't do anything. That's one kind of decision we have to make. If the user's gender is female, ask for a maiden name. If it's a male, don't even bother to ask. That might be a bit sexist. I don't think that's changed much yet, though. Another type, most common type of question, if the answer is true, do one thing. If it's false, do something else. If the balance is overdrawn, say so. Else, tell them what their balance is, how much they still have to spend. We could do processing in different ways. And finally, as I gave you an example before, multiple choice. There are lots of ways for us to let the user make decisions on the screen in a GUI type environment. Most common are checkboxes. Are you a full-time student? Yes or no? Do you wish to contribute manually? Yes or no? Checkboxes let you do that kind of stuff. Radio buttons are also very handy if there's a small list of choices. Here's 6 hockey teams. Which one's your favorite? If it's a larger list, like the entire list of the teams of hockey teams out there, then we might use list boxes and combo boxes to make selections. That's next unit. So in this unit, we're going to focus on checkboxes and radio buttons to let our user make choices. When we were in unit 3, back in design days, sounds like a long time ago, but it wasn't that long ago. In the design assignments, we mentioned that I taught you how to do design of sequential processing logic, but we'd handle the decision and the repetition processing when we got there. Well, now we're here. So we have to learn how to design decisions. The way you put decisions into your pseudocode is using an if statement. Because just about, I want to say every language uses the keyword if to ask a question. As the program is running, at this point, pause, ask a question, and process in one of two different ways. So this is pseudocode, what you're looking at here. All you have to really do is add the word if. And so that we know when to quit, another keyword in pseudocode, end if. If it's raining outside, notice this is called a simple decision, a simple if. Of the three different kinds, it was the first one that I mentioned. If it's raining, put on your jacket. Take your umbrella. And then go for a walk. If it's not raining, we still take a walk. We just don't take all the extra stuff. So if this is true, we do what's indented here. Indentation when it comes to decision processing is very important. Shows ownership. I can see just by looking at this that I'm going to take a walk regardless of whether that condition is true. And that taking a walk is not part of the condition. The second kind is called an if-else. Almost all languages use the keywords if and else. If I have a test tomorrow, study. Else, I'll watch a movie. But notice that eating supper and going to bed have nothing to do with my test tomorrow. I eat regardless. And I eat before I study, and I eat before I watch a movie. The way this is written. Eat supper. Then make a decision. Should I study or watch a movie? When that's done, either studying or watching a movie, then I go to bed regardless. So these are the kinds of questions that you can ask. If statements only answer true-false type questions. So you have to be able to phrase your question in a true-false manner, in a Boolean manner. So I can't ask if your favorite color or what's your favorite color. I can ask if it's red or it's blue or it's green, then do this, otherwise do something else. Those are called compound conditions where there's three conditions. Is it red? Is it green? Is it blue? Compound conditions we'll talk much more about later. They get kind of complex sometimes. So these are basic if statements. When we flowchart them, we use diamonds. So I'm just going to do a quick shift here and open up Visio just to show you how I build them in there. Still using a basic flowchart. The basic flowchart includes a diamond. And the diamond is really the only tool that we're going to be adding now to our flowcharting arsenal. Even when we get to decision processing, it's still a diamond. I'm sorry, when we get to repetition processing. Looping, doing it again and again and again, simply includes a decision. Do I do it again or don't I? So we use diamonds for the rest of our flowcharts, and that's the only symbol that we're really adding. So if I wanted to do that raining thing, I can ask a question. And before I do, let's change my design here so it's a little easier to see. And then I'm going to start typing. Inside the diamond, you ask a question. In programming terms, the question is called a condition. Under what condition what condition am I checking? So in here, since it's a diamond, it has to be a question. I don't have to add the word if. Many of you will inside the diamonds, and I'm okay with that. But I could just say, is, please, oh, now you're gonna do it. Is it raining? And how verbose you get, is it raining, or just is raining, or just raining? Question mark. Okay, that's acceptable. Now, if raining, if the answers are yes, no, and sorta, then this isn't going to work. But I'm assuming a yes, no question. Whenever you see a diamond in a flowchart, that's a yes, no question. Whenever there's a yes, no question, you, the programmer, or you, the designer, have to handle both sides of the question. What if the answer is yes, what do I do? And what if the answer is no? In general, if the answer is yes, I like to go to the right. Maybe it's because I'm right-handed. I don't know. It doesn't really matter. And do something. If the answer is no, I go down this side and I do something. I still use my connectors. These aren't going to connect very well, so I'm going to have to, actually, let's do this. I'm going to cheat. Now I can touch up here, connect them, and if I move this, it should move the line. Now that's not too good, but I can grab these things and move the connectors. Oh, that's really ugly. I deleted that one. What might have been easier is just to shift to the connecting tool. So on the home tab, here's the connector. Touch on that end, drag it to that end, and drop it. Touch on this end, drag it to that end, and drop it. And when you're done, remember to turn that connector tool off and go back to the pointer tool. So in the condition, in the box, you ask a yes/no question. Be as verbose as you need to be to make it clear. And then one side is yes and one side is no. There are no rules. I tend to, in one flowchart, always have yes on the same side, no on the same side, just so when somebody's reading it quickly, they know which direction to look. So if this is my yes side, I should label the line in case it's not clear. And to label a line, you simply select it, start typing. You can put yes on these lines, true on these lines, raining on this line. Something so that I know which direction to go. I tend to lean toward true because in programming, that's what we say. We don't do yeses and nos, we do trues and falses. So I use true and false. Come over here, select the line and just start typing. Visio will automatically put it in a reasonable location. If you don't like it, select it. And that little yellow dot, let's zoom in so we can, the dot didn't get any bigger. But that little yellow dot I can use to move this. So if it puts it in a goofy location and you don't like what it looks like, just grab that little yellow dot and you can move these so the true is a little too close to the corner. I can pull it back. Or if you wish, pull it off the line altogether. Oops. So those are movable now. They didn't used to be. It's very nice. Just be consistent. The lines are long enough. What kind of things can I do over here? Anything. In my notes, it says statements. Statements. What kind of statements? And notice it could be one, it could be hundreds. If this is true, here's a gazillion things you got to do. If it's false, don't do anything. First thing that comes to mind is launching a rocket ship. If the weather's good, here's a gazillion things you got to do. Otherwise, never mind, we'll do it another day. These statements can be anything, and they can be any combination of statements. They could be input statements, parse statements, calculations, output statements, whatever you want them, whatever you need them to be. They can be, and we'll see this in a little bit, another if statement. Oh, the answer is true. Well, then I have another question for you. These are called nested ifs that are inside another if. And they can be nested to any level that you need them to be, to solve the problem, to make your program process the way you expect it to. So these statements can be anything but, and I haven't seen too much of this yet this semester, so I give you credit for that. What you can't do is put more than one statement inside of a box. Every statement gets its own box. So if I wanted to have 3 or 4 things going on here, I could just hover and make another box and make another box and so on. The flowchart does not need to be balanced. Just because I have 3 boxes on the right doesn't mean I have to have 3 boxes on the left. You still use parallelograms if it changes the screen. So a question, label the true and the false. Doesn't have to go right. If you prefer to go left, you can. And then when you're done, what always happens is every if statement, the true and the false parts come back together again. In my notes, it was kind of obvious because we stopped indenting and there was this end if. Here's the end of the question. Here's the end of the true part. Here's the false part. And this isn't part of the if because there's the end of the if. In flowcharting, there's an end if. We use a connector. I put an end if in there. Zoom out so I can see it a little better, and once again go to my handy dandy connector tool from here to there, from here to there. Zoom in so you can see what I did. And then we continue on with the next command, whatever it happens to be. Come on. All right. So every if statement, the two pieces parts come together into an end if. Occasionally there's a path like the raining one where the answers do nothing. What do we do over here? Nothing. Well, if you don't do anything, you just can leave the box blank. And now that looks a little funky, but it's okay. But what I prefer to do if the answer is do nothing is bypass this little detour. So I'm going to grab the connector here, maybe. I'm going to grab the connector, select the line, and move it down here. And so really, if the answer is true, yes, it's raining, we take this detour and we do this stuff. If it's not raining, we just drop straight through and keep going. Now, the one thing I hope you recognize here is that in flowcharting decisions, it's not a one-to-one translation from what you did in pseudocode. When we were doing sequential processing, for every box in your flowchart, there was a line in pseudocode. For every line in your pseudocode, there was the exact same box in flowcharting. Not necessarily true here, because in pseudocode, we have to write text that says if and else and indent them properly. And in flowcharts, we have to use diamonds and paths to solve that same problem. But they're still pretty close. This same question would probably be in my pseudocode with the word if. The end if is here, where they both come together, and they always come together. Regardless of how complex they get, they always come together. Questions so far? Two paths, that's it. What if it's multiple choice? What's your favorite color? Red, green, or blue? If the answer is red, we say, okay, your color's red. But if it's not red, then we have to ask another question. Well, is it green? Yes, then do something. No. Well, that must be blue because it's not red, it's not green. All we have left is blue. Sometimes it takes more than one yes or no question, kind of like 20 questions to get to your answer. But you can do that. So we took a look at this. There's always two paths. Label them either yes, no, I prefer true, false. One path, like in the example that I did, could be do nothing. It's still labeled. It's still the false path, but it's do nothing. If you have a do nothing path, it should always be the false path. The true should not be do nothing. It looks okay in a flowchart, but when we get to pseudocode, it doesn't look very good at all. There's an example. Come on. Oh, I am there. There's an example here. A little later. I'll get back to it. Two divergent paths, they always come back together. If you have a statement that occurs in both paths, it's on this side and on that side. What if I made a mistake and it said, if it's true, then eat supper and study. If it's false, then eat supper and watch a movie. Well, eat supper's on both sides of the if statement. There's a pretty good chance it doesn't belong there, that it belongs above or below. We're going to see another example of that here in just a minute. If you're typing this code or you're drawing a flowchart and you find yourself putting the same box on both sides of the if statement, it's probably not right. I call it duplicate code. If you ever need to change that box's code, you're going to have to change it on both sides of the if statement, and that's not a good plan. So if you find yourself writing the same code twice, there might be a better way. I'll be impressed if you come over and say, I'm writing this on both sides, the true and the false, but I can't figure out whether I can remove it or not. I'm glad you recognize that it's on both sides. That's a good start. Then we'll figure out whether, and there's only two places it can go, before or after. And if neither one of them makes sense, then maybe it needs to stay. where it is, but not always. Statements can be anything. We talked about that, and the label can be just about anything as well, but I stick to true and false. In pseudocode, I start with an if. You might capitalize it if you wish. I end it with an end if. I have the word then in here because the Visual Basic programmers like it, and you'll often see it in books. Pseudocode includes the word then, sounds a little more English-like. If it's raining, then do this stuff, else do that stuff. Notice the indentation, critical here. The square brackets in my notes mean optional, so you don't need to then. In C#, we don't use the keyword then, so you could leave it out of your pseudocode, it still makes sense. If it's raining, do this. The keyword else is used in all languages, but if you have a do nothing situation, you can leave the else out and not have an else. You should never have an if with nothing underneath it, and you should never have an else with nothing underneath it. The else you can remove. If the if has nothing underneath it, if I type that in Word, I'd probably get dinged for duplicate words. Right? Has nothing underneath it, you need to flip your logic. We'll talk about that a little bit more in a second. If there's no statements under the else, leave it off. That's what the square brackets means here. You don't need it. Just leave it out. Not every if has an else. The reverse, however, is true. Every else has an if. Has to start with an if. Three kinds, or a couple of different kinds of ifs. The simple if that we've been looking at already. Here's the finished version of it. If it's raining outside, put on your jacket, display, take the umbrella, and then tell them to take a walk. It's a simple if. It only has one path, the detour I call it. Otherwise, we just drop straight through. Here's what it looks like in pseudocode. Notice the translation is pretty close. Display, display, if. In here, I put an if. You don't necessarily need to. And then at the end, take a walk. But the indentation, particularly in pseudocode, is your job. Make sure you indent. Here's the true part. Especially in the next phase, it's very important to distinguish where does the true part end? Where does the false part start? Where does the false part end? Indentation is what shows that. C#, Visual Studio, will help you. It will indent. When you type the word if, the next line, it automatically indents it. Occasionally it messes up. If it doesn't do it, you do it. You are responsible for indentation, even if C# screws it up. Other languages don't do it automatically. You've got to know to do it. It's critical. So I like doing pseudocode in this class because nothing does it for you automatically. You have to know to indent the stuff for true and indent the stuff for false. Here's that example about having an if with nothing inside it. I might say, if it's not raining, skip the, if it's not raining, do this nothing, and then skip the else. You need to know, I'm going to jump ahead just a smidge here. You need to know that only one path in pseudocode is going to be followed, either this one or that one. There is no way with an if-else to do both. The flowchart makes that very obvious. How do I watch a movie and study for test in this example? I can't do it. I do one or the other. I cannot do both. So you, the programmer, know that you do this block or you do that block, but you never do both in an if-else. So if I go back up now to this one, I do the if block and there's nothing there. Or I do the else block. So if it is not raining, if that's true, notice this is a negative condition. It's asking if it's not raining now. I flipped it around. Then it does nothing, skips the else, and we take a walk. And then there's an else. So if it is raining, then you put on your jacket and take an umbrella. If I saw it in code, would be very confusing. Because my mind quickly jumps from if, sees the indentation, and says, if it's not raining, I'm taking my jacket and my umbrella. Well, yeah, that's what my mom would say, because it could come up anytime and start raining. But that's not what the logic is here. What we need to do with this is reverse the logic so that the do something is true and the do nothing is false. If there's a do nothing, it should always be your false path. Reword the question so that that's how it turns out. Here I reworded it just to give you a bad example. If you write code like that, I promise I'll let you know that's not the right way. If then else, or just if else, we follow one path or the other, never both. But the two paths always come back together again. We've seen this before. Eat supper, always. If you have a test, study. Or else, otherwise, watch a movie. Now in this example, I could easily flip the question and it wouldn't have any problem. If you don't have a test, watch a movie. Else, study. Perfectly acceptable. Some people prefer a positive question versus a not question, a negative question. Really doesn't matter much. As long as both paths have something to do. It's when there's a do nothing that it matters. And in this case, again, we see the indentation. I only do that one thing if I have a test. I only do one thing if I don't have a test. But after this if statement is called a construct, after the construct is done, here's where it ends. Regardless, I go to bed. Here's the flow chart. Eat. Figure out whether I'm studying or watching a movie, not both. And this is, be careful here. All right, you could accidentally flip the trues and falses. If you flip them around and you've got the wrong stuff underneath, then it doesn't match your pseudocode. It's a very common mistake. Remember, in an if statement in pseudocode, the true part immediately follows the if. Always. The true part follows the if. How do you know that? I just told you. You're the programmer. The false part follows the else. So in your flowchart, they should be the same. False, movie, yep. True, test, yep. And then after everything comes back together again, we go to bed. Now I mentioned to you if the same command shows up in both paths, I don't have it in my flowchart, but here it is in my pseudocode. Eat supper. In the true part, eat supper. In the false part. Go to bed in the true part. Go to bed in the false part. It's in both parts, the true and the false part. If it's in both parts, it's duplicate code. If I decided I want to change it from eat supper to eat dinner, then I have to remember to change it in both places. Or change go to bed to hit the hay. I got to change it in both places. Or someday I'm going to run my program that's going to say go to bed. I'm not going to know what to do because I only know how to hit the hay. It's duplicate code. And duplicate code means duplicate maintenance, and we don't want that. There's a better way, usually a better way, not always, but usually a better way. If you find yourself typing the same thing or copying and pasting into the true and the false, stop. Think about a better way. If you can't come up with one, ask me. There might not be one. Chances are pretty good that you should have the supper first because it's always at the top, and the bed after because it's always at the bottom of the true-false sides. It's a better solution. Way back in Unit 2, I said, if you come up with a solution that works, code it. I will not mark you wrong for doing it wrong the first time, but if I give you a suggestion that you got duplicate code here, you should move this above and you don't fix it, okay, now I'll mark it wrong. But come up with a solution and code it. Yesterday, I was in Wisconsin Rapids, and we were trying to convince sophomores in high school that Mid-State's a good place to come because we got lots of cool things to do. So the students in Rapids, the programming students, wrote some games. They had a tic-tac-toe game. They had a rock, paper, scissors, lizard, spot game. They had a couple other things that they were showing off. And during some of the lulls, I was looking at their code. There's a lot of redundant code, which makes it very different, makes code a whole lot longer than it needed to be, so it's a lot more typing, though you can cut and paste. But if we ever wanted to modify it, we have to change it in multiple places, or the program could have errors in it. So we're trying to avoid. I didn't mention anything because they were volunteers helping us sell sophomores on mid-state. So I said, nice program, good job. And it looks great when it's running, it works. But remember my philosophy, you're not here to learn how to write good programs that run. You're here to write good programs that run and are maintainable. Because that's what comes next. And that's the expensive part of programming. Writing programs, believe it or not, is not expensive. It's the maintenance. After it's done. And it lives for another 20 years. You've been working on the same program the whole time yet, Paul? Pretty much. Yeah. 5 years, same program. It's still not right? Well, no, they just keep enhancing it or occasionally finding a bug that needs to be ironed out. And that's the expensive part. The harder it is to maintain, the harder it is to add things, the harder it is to find problems, the more it costs. There is another construct called if, then, else, if, which basically means after I get a true, or if I get a false, then I need to ask another question. Get the color of the stoplight. If it's red, stop the car. Well, if it's not red, there's three choices here, so I'm not done yet. If it's green, notice there's an else immediately followed by an if. So if the answer is false, then ask another question. Is it green, maybe? If it is, then speed up, right? Oh, actually, that's what the yellow one should say. Green is just keep going. Else, notice the else does not ask the last question. It's like me asking Sean, are you female? No. And then I ask him, are you male? Well, it seems kind of like a redundant question. And it would be. If there's only three light colors, I don't need to ask about the last one. If it's not red and is not green, it must be yellow. So use caution. Another very common programming mistake is to ask the question when there's really only one answer left. Shouldn't do it. Experienced programmer would look at it and say, why are you asking that last question? It's the only option we have. Just do an else. An else is quicker than an else if. An else if, the if part has to be processed by the compiler. Slow your program down by a couple 3 billionths of a second. And it'll confuse the maintenance programmer. It'll slow them down for 5 minutes trying to figure out what other options are there. So you don't ask that last question if you can avoid it. So this last else can often be used for catch-alls. You were supposed to answer networker, software developer, or accounting. And I didn't get any of those, so I don't know what to do because the program only processes those three. You can use an else sometimes to be a catch-all. Say, I don't understand or I don't recognize that program. We're going to get lots and lots of examples of these. This is how I flowchart else-ifs. If the answer is true, go this way. If it's not, I have to ask another question. I immediately, and notice I'm dropping down the bottom instead of out the side. Usually if there's processing, I go out the side. But for else-ifs, I come down this way. And the book on page, at least according to this, 219, so let's go see if we can find it here real quick. The book does it a different way. Whoa. Now that's more questions, right? He's trying to figure out what grade do you get. If you're less than 60, then you fail. Otherwise, if you're bigger than 60, are you less than 70? Notice how he phrases that. Are you between 60 and 70? If that's the case, then you get a D. No, I'm not between 60 and 70. We're working our way up. If this were mine, I'd have all these diamonds stacked underneath each other. And then the true goes out the side. So I do it a little differently than the author does. This, if you have lots of questions, can take up an awful lot of room real fast. I think mine's a little cleaner. but that's just my opinion. I could have 60, 70, 80, 90, and then the answers go out the side. But notice they all come together, even though there's multiple ifs here. I see this as one big construct. I'm trying to figure out your grade. I'm trying to figure out what to do with the traffic signal. There's one end to this, is the way I draw those. And in a way, he's done the same thing, because they all come back together to here. I think this is it's easy enough to understand, but I think mine, you can grab it real quick. You're going to take one of these paths and then get out. It's called an else if. Most languages allow you to do it. Visual Basic even has an else if, it's one word, command. Most languages you just say if, else, immediately followed by an if, space, and it works. So that's pretty much the design of making true-false question decisions. Oops. One more thing. Occasionally, when we ask a question, we get an answer and we have to ask another question. In this case, we're going to ask this person how many years you've been working here and how much stuff did you sell. If you've been working here more than 2 years is basically what that says, and I could have put it in English. If years of service is more than 2, that's a greater than symbol. You'll learn about that next week. If it's greater than 2, yes, then I have to ask another question. Did you sell more than $5,000 worth of stuff? Yes, okay, then your commission rate is 20%. I've been here more than 2 years, but I didn't sell $5,000 worth of stuff. Okay, then you get a reduced commission rate of 10%. If I haven't been, now this is all part of the true, right? This says I've been, come on. It says I've been here, PDF file. I've been here more than 2 years. All of that is under the yes, I've been here more than 2 years. Now here's the else that lines up with that if. This else belongs to that if. The indentation, again, is critical. They need to line up, and here's the end of it. Very important that they line up right. Here's a false. No, I haven't been here more than 2 years. Well, then we have different sets of questions. Did you sell more than $2,000 worth of stuff? Our rookies, we expect a little less of them until you've got some more experience. Did you sell more than $2,000 worth of stuff? Yes, you get a 15% commission. No, you get a trickle commission, and we suggest that maybe you get some more training. Notice again, there's not necessarily balance. Here it's one line, 2 lines. There's no rule anywhere that says these things have to balance. You ask the questions and process based on the yes or the no. There's no balance necessarily. Let's save this for next week. Next week on Monday, I'm going to fly through this one more time just to do a quick review. And then I'm going to ask you to draw a flowchart on whether or not you should buy a large screen TV. For me, the answer is usually yes. All right, but we're actually going to be conscious consumers here, unlike my son, who doesn't matter if I got the money, I want it, let's go. All right. I won't mention which son, that way I can't get in trouble. But we'll be conscious consumers. We're only going to buy it if we have the money. And we're going to pretend to write an iPhone app that helps you decide whether to buy a large screen TV. That's useful. Not really. But it's a simple question that we can deal with. And we'll get to the more complex question a little later. Okay, I don't have the cash. What about my credit card? Can I charge it? Well, I don't have enough on my credit card. I want this TV. Do I have enough cash combined with a credit balance to, now the question's getting complicated. And we'll take a look. We'll do that next week. Enough theory for today. Rest of the time is lab for you to work on whatever you got to work on. If you're still dinking around with Unit 3 designs, my advice now is finish one of them and code it. Do the Unit 4 stuff. Then go back and finish the design for your money changer, for instance, whatever it might be, and code it. Because you need to get some practice with Unit 4 before it disappears from your heads.